if we can take the derivative of a matrix, which we can, and multiplies two square matrices, which we can, then we can set up an equation x prime equals a times x, where x is a matrix rather than a vector. We will see that such equations are basically identical to vector differential equations. If we can solve one, we can solve the other. We'll start with vector equations. X prime equals ax, where a is n by n. This equation has n linearly independent solutions, which we can find using the techniques of previous sections. Call them x1, x2 to xn. We define the fundamental matrix of this equation to be phi of t equals the matrix with these solutions as columns. We say the fundamental matrix. Of course, different choices of eigenvectors and generalized eigenvectors when we solved this equation give different solutions and different fundamental matrices. However, fundamental matrices are unique up to matrix multiplication. If phi and gamma are fundamental matrices, then phi is a constant matrix times gamma. Back to this equation. The derivative of a vector equals a matrix A times that vector. We use it to define a fundamental matrix phi. Then phi is a solution to the corresponding matrix differential equation. The derivative of a matrix equals the same matrix A times that matrix. Now consider the matrix differential equation. Suppose we have solved that. With the matrix X hat being a solution. Then each column of X hat is a solution to the vector equation X prime equals AX. And because there are n of them, we have a general solution. So if we can solve a vector differential equation, we can solve the corresponding matrix differential equation. Put n linearly independent solutions of this into the columns to solve this. And if we can solve a matrix differential equation, we can solve the corresponding vector differential equation. Take the linear combinations of these columns. Therefore, solving matrix differential equations is equivalent to solving vector differential equations. We do not need special techniques. In this video, we have discussed matrix differential equations and fundamental matrices. We'll see shortly that thinking of systems of linear equations in terms of their fundamental matrix can be useful if we want to vary our initial conditions.